Good evening, everyone. I hope everybody has come now, but it doesn't sound like that. It's okay, good evening. So, today we are going to start with mathematics and it's chapter 6. The topic is the triangle and its properties. Remember last period, like last class when I had taken, it was just regarding chapter 5. And what it was talking about? It was talking about lines and angles, right? So that time we talked about the lines, and with the help of lines we are forming the angles. But you also know very well that with the after having the angles, a number of angles, we are also forming the triangles. So this is the second part, you can say. So when we go for the triangle, here in this chapter we are going for the triangle and its properties. So how many kinds of triangles are there? Means we know triangle. Triangle is what? Which is having three angles, right? Okay. So what we find here, we are having three angles, triangle. So when we go for tri and angle, it is means tri means three and angles means the angles. So here what we get to know, triangle means the three kinds of angles. Means a kind of structure, a geometrical shape which is having three angles, is actually known as triangle, right? So it's very easy to draw any triangle, right? We can draw any triangle here. That's okay. But is there any kind of difference? Do we have the kinds of triangles as well? Yes, definitely I must say, before going through the properties of the triangle, we should know first how many kinds of triangles are there. When we go through the triangles, means the properties like the kinds of triangle, after that we can get to know that what are the basic properties of a triangle. So first, I want to know from you people that do you know how many types of triangles are there? Means on the basis of what we are having the triangles. This is a very common question. Okay. So on what basis we are having the triangles? Okay, we are having actually the triangles, the variety of triangles or the kinds of triangles on two bases. What two bases? What a triangle has. You just think what a triangle has. A triangle has base, means a side, and the triangle has an angle, right? So here also we are going for the the kinds of triangle on the basis of two things. First, we'll go for it on the basis of angles. Second, we'll go for on the basis of sides, right? So first, why don't we start with the sides first? Better we'll start with the sides only. So let's go down somewhat and we'll just go for the introduction here. So what is the introduction? What is the basic thing a side has? Means a triangle has. So we find a triangle has means when you were there in class 2, 1, that time only it was taught to you that a triangle is having three sides, right? Three sides it has. Side AB, side BC and side AC. But here how to write it, as it is a side, it's a line segment we can call it. So it is just like this. This line is very important because it says that it is a line segment, right? So here whenever the name comes to write it down, so you have to write the angles are, means the sides are AB, BC or CA. There are three sides we have. How many angles it has? Undoubtedly three angles it has. That's why it is known as triangle. So three angles it has. Angle A, angle B and angle C. You can write it in a different way as well. So angle A can be CAB. So if you're talking about angle A, so A should be in the center. So what we mention, CAB or you call it BAC, doesn't matter at all. Okay, doesn't matter the way you write or you mention it angle A. All the three are the same angle. Remember, means only one angle and I have given it three names and all the three names are perfectly correct. Now coming to second angle. Second angle is angle B. Okay, we can call it as angle ABC or we can call it as angle CBA. But what is common here? B is in the center. The same is angle C as well. So angle C will be angle C, angle ACB or angle BCA. But C will be in the common. So we found that a triangle has 3 sides, 3 angles and 3 vertices. 3 vertices means what? Vertices means what? The meeting point, right? The meeting point here. The meeting points of 2 line segments is actually known as vertices. So how many vertices we have? 3, and it is like this, A, B and C. We are just supposed to mention it like that. Now we are coming to the another kind of means. This is the basic concept what a triangle has. Now I'm coming to the next one, that here you can find that a triangle can be defined or classified into 2 parts, means into different categories, but on the basis of 2 things. First, on the basis of side. I think you have gone through it in class 6 as well, right? So it is having 3. Which 3? So you just see here 3 are which 3? So you just see we have the scalene, isosceles and equilateral. So what does it mean by scalene, isosceles and equilateral? So you just see equilateral means all equal, right? The name only says equilateral means all equal. So we got to know equilateral means all equals. As we are talking about these sides, means it is having equal sides, right? The length of all the sides is going to be same. So when we take a triangle which is having all the sides equal, means the length of all the sides is similar, we call as equilateral triangle. Okay. Second comes for isosceles. What does it mean by isosceles? So you just see isosceles means it is having 2 sides equal. 2 sides equal. You see here there are 2 sides which are almost equal and the third side is completely different, right? So here what we find, this is called an isosceles where 2 sides are equal. As we are talking on the basis of sides, so we are talking only and only about these sides, right? So equilateral means all sides equal, isosceles means 2 sides equal. Equilateral means all sides equal, isosceles means 2 sides equal, and when we talk about scalene, it has nothing equal actually. Now you can have a query that how can we have nothing equal? Small, then big, and this is the biggest one. So you just see here 3 different sides are there, mean 3 different sides, 3 sides of different sizes. So this is called the kind of triangle on the basis of side, right? Now we are coming for the 3 kinds of angles, like triangles on the basis of angle. So when we have the on the basis of angle means what? Acute angle. Acute angle. Acute, you know, means previously only we were going for acute. Acute means which is less than 90 degree, which is less than 90 degree. So you have to think that what is acute angle. We know that when one property you know very well, that when we talk about a triangle, the sum total of all the angles is supposed to be 180 degree. Okay, it is supposed to be 180 degree because it is a triangle. So completely it should be 180 degree. Now I'm talking about acute angle. So what is the acute angle triangle? So here we find acute angle triangle is a kind of angle, is a kind of triangle which is having all the angles in this, means all the 3 angles, angle A, angle B and angle C, all the 3 angles are supposed to be less than 90 degree. This is called acute angled triangle. Acute angle triangle means all the 3 angles are supposed to be less than 90 degree. Now you may have a feeling, is it possible that all of them are supposed to be less than 90 degree? Yes, it is undoubtedly possible. Let's have it. We can take it as 60, 60, 60. If you take it at 60, 60, 60, it is 180. If you take it as 70, 50 and 60, again it is 100 degree. But what is common here in both? This is again less than 90 degree. This is again each and every one is less than 90 degree. So what is acute angle triangle? So remember, acute means less than 90 degree. So acute angles means all the angles must be less than 90 degree. Now coming to the next one, what is the obtuse angle? obtuse angled triangle. So here we find that obtuse means which is more than 90 degree, right? Which is more than 90 degree and less than 180 degree. So here comes that obtuse angle triangle is the kind of triangle which is having at least one angle. It will have only actually one angle as the obtuse angle, means one angle must be more than 90 degree. So how can we draw that? Just take this, draw an angle. So what is it? It is undoubtedly more than 90 degree, right? When it is more than 90 degree, we call it as, and then I just merge it. What I find? One angle is more than 90 degree and rest two angles are actually the acute angles. So what we find? A kind of triangle which is having one angle more than 90 degree, or one angle is obtuse angle. That angle is known as obtuse angled triangle. Okay, now we are coming for right angle. So easy for you that you know very well. Right angle, so means undoubtedly one angle is supposed to be a right angle, and this is the formation. So what we find? Acute angled means all the angled, or means acute angle triangle means all the angles less than 90 degree. Obtuse, undoubtedly one angle is supposed to be obtuse, means more than 90 degree. And third is right angle triangle. Right angle triangle means one angle is 90 degree and rest all will definitely be acute angle. Because if one is only 90 degree, rest cannot be more than it. Rest will undoubtedly either 60-30 or 45-45, whatever it is. But it is on the basis of that. So we got to know about the kinds of triangle. They are on the basis of, based on sides and based on angles. So this is the recap of it. Now, here we are coming for the try these. Let's go for the try this. The question comes like this. This is a triangle. Okay. And what you have to write down, the opposite side of the vertex P, of vertex Q, P, Q, R. So I am telling you the angles you got to know, right? You the sides you got to know. Now the matter comes that what to say when we are having this is Q. What is its opposite side? So PR will its opposite side. Here is P, QR is its opposite side. Here is R and PQ is its opposite side, right? This is the vertex. What I said, this is the vertex and its opposite side is this. This is the vertex, its opposite side is this. This is the vertex, its opposite side is this. Okay. Now, just opposite to that we'll go for. Just opposite to that. I have taken the angle. This is the triangle PQR. Okay. This is the triangle PQR. As first I told you, the angle is given, means the vertex is given, and you have to find out the opposite side, right? Now I'm asking, this is PQ. Sorry, this is PR. So what is the opposite vertex of it? Just opposite to that, or the angle of it. The angle opposite to PR is what? The angle Q. The angle opposite to PQ. Angle opposite to PQ is what? It's Q. It's R. Angle opposite to QR is angle P. So here just it goes vice versa. How? It will ask for one and it will ask for rest of the things. Opposite sides, opposite vertex, opposite angle, they all are coming in the same way, right? Now we are coming to the next point. That's why I called I just said that we need to find out, we need to go for basic property, the basic revision of it. Now coming to this, here what it is just on the basis of sides, because the side is actually written in centimeter, I mean the length of the size is given. So here you have to find out the kind of triangle on the basis of the length given of the sides. So what do you find here? When you go for first one, what do you find? Two triangles, means two sides are 8 centimeter, 8 centimeter, means two are same, one is different. So when two are same, one is different, what it will be? Isosceles. Two are same, one is different, it will be isosceles. Here we find that all of them are different. One is 6, another is 8, another is 10. This is known as skeleton. Here in this one we find that 2 are there. 7, 7 means 2 are same, and undoubtedly third will be different only. So when two sides are same, that is known as isosceles. You just see number 4. The length of all the C sides there 5.2, 5.2, 5.2. So when all of them are same, that is known as equilateral. Equilateral means equal, right? Here you see 2 are same, third is different, that is known as isosceles. And the last one again, 2 are same, 6 centimeter, 6 centimeter. So when two sides are of the equal length, we call it as isosceles. Okay. So tell me, do you have any doubt till here? Then we'll go for the next, because this is something which is already taught to you. This was the revision part from class 6. Okay. Now we are coming to the part that please let me know if you have any doubt. If you have any doubt, please let me know, else we'll go ahead. Okay. Fine. So I think there is no doubt and there is no response as well. So here we find that maidens of a triangle. What does it mean by maiden? Maiden means what? Okay. We can call it median or we can call it maiden. So here we find that what is maiden of a triangle. So what it will be? Okay. Good. So we find here maiden of a triangle. So let me tell you till now what we talked about. Basically we talked about one thing, that this is a triangle and I just draw a line on it. How many lines I can draw? As many lines, right? What I did, I have taken a triangle from and the name of the triangle is ABC. What I do here, with the help from the angle or from the vertex A, how many lines I can draw on the opposite side? I can draw, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Means as many as we want, we can draw from only one vertex to the opposite side. We can draw as many lines. Okay. So that's very common that we have drawn a number of lines over here. But here comes two special lines. What those two special lines are? So we'll go for specially those two special lines. And those special lines are, let's see. So those special lines are, you just take a triangle from this vertex A on the side B and C, on the side BC. What you have to do, draw a line which is directly perpendicular to it. Perpendicular to it means perpendicular on BC. I just name it D, and it is perpendicular on BC, means it is making the angle of 90 degree. It is making the angle of 90 degree. So what is a perpendicular line? Here we find BC, AD is perpendicular to BC. AD is perpendicular to BC. So this is the angle. This shows, here you just see AD is perpendicular to BC. It means AD is the line which is directly perpendicular, which is making an angle of 90 degree with BC. This is actually the basic concept. AD is a line. AD is the line which is perpendicular to BC, means it is making the angle of 90 degree with it. And whenever you go for this symbol, you definitely can see that it is the symbol of 90 degree. It is a symbol of perpendicular line, right? When we talk about the parallel line, so we just mention it like this. But this is the perpendicular line. Fine. So here what we find, one line is going to be very specific because it is going to be directly perpendicular on it. So how can you make the perpendicular line on it? That matters a lot. How can you draw? Nothing to draw. You just take a scale and you draw. Why? Because it will not give you that kind of information. May it will reach here, may it will reach here. It can reach anywhere. So what you need to do, you have to just draw a line here, and straight to that you have to draw a line. So when you're drawing a line over here, it is formed as, it is called as the perpendicular line. And perpendicular line is what? This is something different. Okay, I'll give you one more example here. So here we find there are two lines. One line is the perpendicular line. Second line, which I told may be very special, and what that line is, this is BC. Okay, ABC, A, B and C. And what you need to do is draw a point or draw a line or find out the midpoint of BC. This is BC and you have to find out the midpoint of BC. Now you may have a query, how can I find it out? So you know very well that in class 6 also you went through it. And what was it? You put your divider, with the help of divider and the pencil you did that. So you kept one point over here, another point more than half, and cut this side, for another side cut this side. What you find, it is giving a dot, and this dot is actually coming exactly in between, right? Do you remember that? If there is a line, you take this line AB and you want to draw a straight line and from the center, straight line from the center. So how will you do? You just take the protractor and means compass. You take the compass along with the pencil, keep the point of the compass this side at B and take more than half, just imaginary, more than half, and put a cut mark over here, put a cut mark here. Now another one, you just put the compass over here, one point of compass over here, and then again the same length. It is compulsory that length should not change. So here you go for the same and same. What makes it here? It forms a straight line, and it is in the center on the line. Means what it does, it divides the line into two equal parts. Means AC is equal to BC. Remember that. AC will be equal to BC if it is done properly. Okay. So here I am going to tell you that which another line is going to be very different. So I have taken this one, not this line. We'll take this one. Okay, I have taken this triangle, and what I'll do, this is B and C, and with that particular way only, with the help of compass, we are going to divide this BC into two equal parts. We'll take the compass and we'll divide it, right? Doesn't matter where this A lie, we don't care for it. What I did, I divided it into two parts, and I found that there is a dotted line, it is here. This is a line actually dividing the entire BC into two equal parts. Entire BC into two equal parts. So here we find this point is actually, if you consider it as D. So here you find that BD is equal to DC. Means BD is equal to DC over here. Now, the line you have to draw. What is the line you have to draw? Take this point on A. So let me change the color now. Okay, I'm changing the color. So here we see, this is the point. So from A to D, you have drawn a line. This particular line segment is actually known as maiden. How? First, how and what? Okay. So here we find first this BC is supposed to divide it into two equal parts. After dividing it into two equal parts, that point should be matched with A. So when you match it with A, what happens? You find BD is equal to DC. BD is equal to DC. So this is known as what? This is actually known as maiden. This AD is actually a maiden. Remember, this AD is actually a maiden because it has drawn a line. It has drawn a line on the opposite side. Vertex A has drawn a line on the opposite side BC at the midpoint of BC. Remember, what is maiden? So the maiden is vertex A draws a line on the opposite side BC, at its midpoint. The BC is having the midpoint D, at its midpoint D, and this line is actually AD, is known as the maiden for it. So two lines we found was very important. first line is, which is coming and which is dividing it into two parts, another is the line which is directly perpendicular to it, which means which is making the 90 degree. So a number of lines can be drawn from one vertex to the opposite sides. Vertex A, from the vertex A, we can draw a number of lines on the opposite side B. But what is very important here? The important thing here is there is one special line, that is AE. It is perpendicular. This AE is perpendicular to BC. A is perpendicular to BC. Second line is very important, is AD. It is the maiden. Why is it maiden? Because it is joining BC but exactly at the midpoint. Okay. Now the matter comes, how many maiden and how many perpendicular lines we can draw. Okay. How many maidens can be drawn? So undoubtedly, if we are having three sides and three vertex, from this one we can have one perpendicular line. From this one we can have another perpendicular line. From this one we can have another perpendicular line on this. So what we find, we can have three maiden in a triangle. Why? Maiden is what? From the vertex to the opposite side. So there are three opposite sides, there are three vertex. So we can have only three maidens here. How many that perpendicular line can be drawn? Undoubtedly we can have the same perpendicular line, number 3. Total number of 3 perpendicular lines we can draw. So understand, please try to understand, the altitude means we can call it the perpendicular line. Altitude of a triangle is called the perpendicular line. Okay. So again we'll have 3 perpendicular line and 3 maiden in each triangle because we are having 3 opposite angles here. So these are the things given, already we have discussed about. So we are coming to the exercise 6.1. So what happens in exercise 6.1? You just see in this triangle PQR. Okay, this is the main triangle PQR. What is the midpoint of QR? QR. This is QR. The midpoint of QR, what do you find? It is having 2 lines here. One is the altitude, which is the perpendicular line. What is the altitude here? It is PM, right? What is the maiden here? That is PD, right? How can you say? Because PM is making the 90-degree angle. So it is the perpendicular line or the altitude. And PD is just between Q and R. It is the midpoint of Q and R. So PD is going to be maiden here, right? So what we need to write, you just see here. In this one, as 2 special lines are there. So PM is what? PM is what? It is the altitude. PM is the altitude on QR, right? PM is the altitude, means it is the height of actually. So we call it PM is the altitude. Coming to next one. PD. What about PD? PD is what? PD is maiden over here because it is dividing it into 2 parts. QR into 2 parts. Now coming to, here you just see QM is equal to MR. Is it possible? QM is equal to MR? Undoubtedly no. Why? Because M is not the point which is dividing QR into 2 equal parts. It is actually D. M is not the point. M is just the altitude for it. But D is the point which is dividing the earth, dividing this side into 2 equal parts. So what we find? It is divided into 2 equal parts. So M cannot be. M cannot be there. So here we can say QM is equal to MR. So we must say no, because if the question comes why, so we must say no, because PM is the altitude for QR. But D is the maiden for it, as the D is the maiden for it, so it will be QD is equal to DR. But if I say QM is equal to MR, it will be completely wrong because M is not the midpoint here. M is not the maiden here. Now, question number 2 and question number 3. Let's see question number 2 what? In ABC, in triangle ABC, B is a maiden. BE is a maiden. You just see, it is talking about the rough sketch. When it talks about the rough sketch, what we need to go for? Rough sketch is completely a rough sketch. What I am doing, that's also a rough sketch. So just see ABC as a triangle, okay, and it should be BE is a maiden. B is a maiden. So I assume that this is E, which is coming in the center, means which is dividing the BC into two parts. Sorry, I didn't give it a name. BE is the maiden, na? So it is not supposed to be like this. I gave it a wrong name. So here B, A, B and C. Okay, here you find that base one is AC. So I have to draw a midpoint here with the help of that. If it is a rough sketch, so we can just divide it. And then I'm going to draw a line over here. This is E. So we find here B is a maiden over here. BE is a maiden. Next one. In triangle PQR, PQ and PR are altitude of a triangle. So what does it mean by altitude? What does it mean by PQR and PR and PQ are the altitude of a triangle? So we just see, when we talk about the altitude, we are basically talking about the right angle. Okay, so you just see here, PQ and QR, PQ and PR. So you just see here, PQ and PR. Here we find, I have made again the name wrong. This is P, Q and R. Because in both the angles, in both the sides, means PQ and PR, P is common. So if P is common, P will be here, common for both. So we find PR and PQ, they are altitude of a triangle. How are they? Because they are forming 90-degree angle. PR is forming on PQ and PQ is forming on PR, right? So they are called the altitude of it. So there is no issue. You can draw anything, but you have to be very careful while writing down the name. Coming to C, in XY, I think you can do it yourself. Coming to question number C. Why don't you do it yourself? Okay, so question number C, you do it yourself. Coming to question number 3. Verify by drawing a diagram if the maiden and altitude of an isosceles triangle can be the same. Yes, undoubtedly it can be the same. Because here we are talking about the isosceles triangle. So when we talk about an isosceles triangle, here we have an isosceles which is having two sides completely equal. Two sides completely equal. This is an isosceles. When you draw a line, when you're drawing a maiden, it is coming here, right? And this line is only making it perpendicular, means making a 90-degree angle. So remember, whenever we talk about isosceles angle, we are basically talking that the maiden and the altitude will remain the same. Altitude and the maiden will remain the same only in the isosceles angle, because they are having both sides equal. So undoubtedly it will draw a line at the center and it will again make the 90-degree angle only on it. That's why we can say like this. Okay, so I think we should end up the class for now and let's join the another class.